Hello everybody. It is great that you enable me to participate in this panel discussion and also in this conference. I would like to present you a specific view on what is a model in artificial intelligence and what is it not. The typical thing is that AI models are often only brute force models. They follow methodology, syntax first, semantics on top of syntax, pragmatism later, and pragmatics is forgotten. Often we see some kind of symptom-based analysis instead of a holistic consideration. We see a context-free analysis. We state something. We have maybe an analysis of somehow obtained data, and we have an assumption that is really very problematic. That is the average case, and mainly concentrating on the average case consideration. And often we think that the normal case is the only one. However, we have also concern-driven AI, search, control, robotics, explanation, production, guidance, steering, translating, and at least I'm happy to know an exceptional good case that is a mathematical model of meaning with the 5D or 6D models behind. However, you should be very careful with some applications that are not at all your friend, and nothing should be considered this way. I'm preaching modelology as a study of models and modeling, as well as of model usage that can be developed as an overarching art and craft for all areas of life, science and technology. That means we can somehow represent what we have in mind in a way that it can be properly handled. So in this case, we need to answer questions like: when does something become a model? What is the journey of a model? What are the characteristics of a model? What quality is expected from a model? To what extent can a model be trusted? Which characteristics exclude being something really to be a model? To what extent is a model suitable or appropriate, at least, in a given application, and when not? And what is the potential and performance we could expect from models? We use for modelology a generic conception of models that can be specialized according to the specific concern, according to the specific application case and the perspectives of the community of practice. A model, in this case, is a well-formed, adequate, dependable instrument that acceptably represents something called origin as source, archetype and starting point, and that functions properly in usage scenarios in accordance with the concerns of a community of practice for a given application case in a situation. We should be aware that sometimes we are using something that is not yet a model. Pre-models summarize conceptions in a pragmatic and sufficiently complete way. However, they are not really representing what we want to have. Proto-models are on the way to become a model if we know how to extend, how to properly integrate, how to properly instrumentize these things so that they couldn't become models. Moreover, I was already presenting this in the last EGC conference, there are non-models and unmodels as the worst case. Classically, people do the following. They use some kind of AI platform in order to analyze maybe data they have obtained. They are using these data as training data. They have some kind of investigation concerning the landscape, and they would like to handle some class of phenomena. That means we are selecting in a language and a class of algorithms. we want to have at least some kind of analysis, maybe with AI pre-models, followed by some validation of results. What is typically forgotten is that it should be enhanced by a proper model development, and it should enable us to investigate. Let's look again for the same picture. What we have after applying such a platform in a data-first and knowledge-minimal data analysis approach, we have some hypothetical pre-model based on potential theory offers and backed by the training data. What we need now to do is a proper model development. Let's call it semantification. And in this case, we use the phenomena we consider and the potentially possible data by a modelizer so that we can finally reason on a conceptual model for our comprehension. Explainable AI is for me, however, the wrong development methodology because of the semantification is done in some kind of ad hoc analysis. What we really want to have is we dream about a theory, and this should be a qualitative theory, maybe with some kind of qualitative conceptions or concepts, maybe supported by our data. However, what we really have is maybe quantitative resources. And maybe we have some kind of hypothesis about potentially theory offers. Then we could have maybe some kind of sources that could represent what we want to have for our theories. However, what we really can do is we use these resources and these theory offers to develop models. Models with their conceptions or their concepts that are supported by the sources we have in mind. The real thing is, however, far beyond our potential situation, typically because of we don't have all the qualitative and quantitative conceptions on hand. That means in this case models could help a lot in order to know what we can do and how we can do it. That means in this case we would like to consider not only models in all cases, we would like to have faithful, honorable models that explicitly specify what is the background and the foundation, the underlying matrix, where we know what kind of toolset we are using and what are the restrictions of this toolset, what is the application landscape in reality, which origins and also donors could be used, maybe with their specific background or meta model, including all their specific features and limitations. Then in this case, we can use SWOT analysis to reason about whether a model is really faithful. In this case, we know what are the limitations, ambiguities, pitfalls, so that we can avoid to misuse a model. There are, of course, also application profiles, prohibitions on use or restrictions on use, as well as the anti-profiles. That means in this case, we are interested in reality, in artificial intelligence, model usage in faithful models. Of course, of very different kinds. One could be a faithful model for representation or presentation. Representation models, they represent what we have in our origins, they represent our background, they represent our matrix in such a way that we are able at least to reason in some, or to visualize at least something. Visualization models go a little bit further. They are representation models, but with a specific facility to visualize certain aspects of a model and thus, and therefore, certain aspects of the region. We could also have a support for imagination by imagination models. They are specific representation models. They characterize, harmonize, and explain the notions, ideas, and concepts along what we have in hand. That is one dimension. The second dimension would be activity models. For instance, we could have instructional models. They guide us and support us through a scenario by somehow ready-made model solutions, and they provide us at least a way that we can handle something in a proper form. Typical activity models are activity flanking models that are somehow supporting us in such a way that we can really handle the application case in such a way that we reach a very good result. A very good example of activity models are production guiding models. They are used for production, manufacture, for creation, for fabrication, for construction, for reconstruction, for restoration, whatever you want. This is already widely used since thousands of years. A third dimension is comprehension. Comprehension means, in this case, a model should be well formed, sufficiently functional and sufficiently clear, in such a way that we can reason on what is really represented about the origins. A typical case is, for instance, a comprehension model in information systems technology, for instance for business models, that is a fully adequate and reliable presentation of the perceptions from the business user perspective to facilitate the understanding and application in the line with the business user specific needs. Comprehension models can be also extended to become full faithful models, self-explanatory and very well founded comprehension models. The typical case is here the conceptual model that we use in IS technology. What means now modeling in artificial intelligence? First of all, we have to formulate in a proper form the problem. What is really the concern? What is representable? What kind of means we have for this kind of modeling problem? And how these models can be properly used. The next step would be, that is already partially done somehow, a proper model formulation. Of course, with corresponding assumptions, with coherence requirements, with some kind of approximations, for instance for causal deductive models, or for simulation, or for comparative analysis, or maybe via some kind of deductive systems for data interpretation, for planning, and for spatial and temporal inference. What we need and what comes from modelology is we are supporting modeling by a skilled use of models within the skills of the user, within the available resources, based on the potential of the model, of course, and restricted by the anti-profile what cannot be handled with a model. And in this case, we should orientate on faithful, genuine models. Okay, that means in this case, it is still a good plan to have a general frame for having a general framework. of modeling. That means one thing is not right for all. Let each one see what he will do. Let each one see where he will stay and who stands, that he may not fall. Thanks for this opportunity to present my thoughts about modelology.